What's up everybody, welcome back. So in the last episode we added our new searching state and chasing states, and in this episode I want to change things up a little bit so AI can alert other AI around them and they don't necessarily alert all AI in the level. So we're going to smooth things out a little bit and make everything work a little bit better if there's multiple AI in the level. So yeah, that's pretty much what we're going to do today. If you like the series, please consider leaving a like, and if you want to get the project files, you can become a member of the channel or a Patreon, and then you will get access to premium channels in the Discord and also premium... Oh, that guy spotted the corpse, okay. And also premium downloads for the project. So let's start today's video. At the end of the last episode, we ended with the output log opened, and we actually got a warning that we attempted to access an index -1 of the perceived actors array. So we're going to fix that little issue first, and for that we need to go inside of our AI controller, and in here we have the on-target perception updated event. If we go to the right a little bit, the branch where we do not perceive somebody successfully, over here we want to add a little check. So if this returns -1, then we don't want to access the array. So we can simply add a little branch in here. And we're going to plug in the execution pin and make sure that the index that we find is greater than or equal to 0. And then plug it in and plug in the true pin. So that will take care of the little warning inside of the output log. Okay, just a little side note. First of all, let's take a look at our EQS. I want to change up how it works a little bit. So I want to change the EQS a little bit so it returns a spot that's a little bit further away from the actual location where we saw the enemy. So if multiple AI spot us, they don't all go searching at the same 10 feet of the level. So for that we want to change our EQS query over here, and we might also want to plug in the EQS testing pawn inside of the viewport so we can actually see what we're doing. So let's do that first. Oh, thank you. So I'm simply going to drop it inside of the level over here and then make sure that it's set up to use our EQS query. So on the right side for the query template, we're going to select our spotted actor location. And now nothing really happens because it doesn't get a spotted actor location returned by our context over here. So if we open up the context, it's reading the spotted actor location from the blackboard, but in the viewport that's not set. So what we can do to make our testing life a little bit easier is simply disconnect this query over here, and we're simply going to enter a location in the level so it will use that location. So for example, if I grab my player start and move it around here, so this is the location I want to use, 1020, 1020, and then height 90. So let's move this guy back. And then for the context, we're simply going to fill in that location over here. So 1020, 1020, 90. Compile, save. So now if we grab our EQS testing pawn and move it around, then you will see it update. So these are the points it currently gets returned by our query. And we're going to open up the query. And in here, I want to add a little dot test to make it pick points that are a little bit more to the side and not necessarily around the actor. So we're going to right click and add a new test, and that's a dot test. Now first of all I want to move this up one spot so it will perform the dot test before the distance test, and then we're going to set it up over here. So this is simply a dot product. If you don't know what a dot product is, it's a very useful way to determine how two points are facing each other. I suggest if you don't know what it is, just look it up on YouTube. There's plenty of short explanation videos about that. Now for the first line, we're going to set it to 2 points, and we're going to draw a line from the querier to the item. So for the first point, that's the querier, and the second point, that's the item. So we're going to draw a line from our EQS testing pawn to one of these dots. And then, excuse me, And then the second line that we're going to use is also 2 points. And for this one, we're going to use the querier and the spotted actor location. So the line 2 is going to be the spotted actor location. So it will draw a line from the testing pawn to an item, and then from the testing pawn to our location that we entered. And then it's going to determine how far these lines are apart from each other. In relation to the angle that they have. So we want to return an absolute value because we don't really care if it's in front or behind us. We only care if it's to the left or to the right. And then for the filter, we're going to set it from 0.8 probably, or 0.85, something like that. And then the maximum value is going to be 1. So 1 is straight in front of us, and 1 is in front of us and 0 is to the side. And then for the reference value over here, for the scoring, we're going to set it to 0.89. So this will pick some points that should be a little bit more to the side. So over here you can see right now over this point is rated 1.99 for the score, and the points in front are 198 and 1.5. So this will actually make it pick points that are a little bit more to the side. And if you actually disable it over here, you can see the difference. So right now the points are spread out differently and they are scored differently. So that's pretty much all we want to do in here. You can play around with this stuff. You can increase the size of the grid and how many points it will return, or change the absolute values. And using that, you can actually play around with this a little bit. So I feel like it should return a bit more points. So right now, if we are unlucky, it might actually return no points at all, or some AI might clutter up a little bit because they all pick the same points. So what I'm going to do is simply change the distance check over here. And I'm going to set the maximum distance to 650. So it will have a little bit more points to choose from. So we're going to leave it at that. Let's save and close this down. And now what we want to do as well is go inside of our behavior tree. And in here we have the node that's actually executing our EQS query over here, run EQS query. And currently I have it set to a single random item from the best 5%. So it will use the 5% of the items that have the best score and then pick one randomly from that. And I'm going to change it to the best 25%. So we have a little bit more randomness in here. Save it as well, and that should be good to go for our query. So now I'm going to remove the testing pawn from our level. And it asks if we want to delete it because it also has an AI controller, so we can simply click yes, that should be good. And then we also want to go back inside of our EQS context and make sure that we hook this pin back up, otherwise it will always use the same location in the level. So compile and save, and our EQS should be good to go. So now I want to take a look at setting up some interaction between our different AIs. Now let's improve our behavior a little bit. So currently we could have 2 AIs in the level like we have over here. And this guy could be alerted, and while this guy does nothing. And that's a little bit weird because in a real life situation, he would probably tap him on the shoulder or yell at him like, hey, I saw something, come and help me over. So we're going to make sure that if one AI gets alerted, he can alert other AI nearby him. But we're also going to add the ability to make a difference in locations. So for example, if there's a wall over here and the other guy is behind a wall and the door is locked, or there isn't a door at all, or he's on a different floor maybe, we can differentiate between them and make sure they only alert AI that are in the same location. So we're going to add that ability as well. And then for the combat state, we're also going to make sure it will alert nearby AI or AI in the same location, but not necessarily all AI in the level if we go into combat. So we're going to smooth things out a little bit. And to do that, first of all, we want to go to our interfaces. And we're going to change things up a little bit over here. So first of all, let's go to the controller interface. And for the change state event, we want to change it up a little bit. We're going to add two inputs over here. And the first one is going to be the spotted actor. So that's an actor reference. And we also want to be able to pass on the search location. So we're going to add another input, and that's the search location, and that's a vector. So that's good to go for the controller interface. And then we also want to go to the pawn interface. And in here, we're going to create a new function, and that's going to be the set location name. So let's prefix it with AI and then set location name. And this is actually going to return a name. So it's not an input but an output, and that's going to be the location name. And that's a name variable. No, not a string but a name. There we go. Compile and save that one as well. So let's set up this name variable on the card. So we're going to go to our card character and open it up. And let me swap my notes as well quickly. So first of all, we need a new variable in here, and that's the actual location name. So we're going to create a new variable, location name. That's a name variable. And for this one, we want to make it instance editable and exposed on spawn. So we can change it for all the AIs that we place in our level. And after that, we want to set up the new function. So we're going to go to our interfaces and double click our set location name over here. And the first thing we want to do is make sure that we actually have a location set up in here. So we're going to grab a branch, grab our variable that was instance editable. So it's either populated or not, depending on if we filled in something in the details panel. So we're going to do a not equal to and plug it in. So if it's not empty, then we're going to set it, and we're actually going to set it on our actor tags. So we're going to right click and get the tags. So that's the default tag variable that's on every actor. And from here, we're going to add an item. And we're simply going to add our location name to our tags. So plug it in over here. And then we're also going to return it with the return node. So also plug it in over here. And if we don't actually have a location set up, then we're simply going to return nothing. So we're going to plug in a second return node and leave that one empty. So that should be good to go. And now we want to go inside of our AI controller to actually set everything up. So again, I'm going to swap my notes quickly. So let's open up the controller. The first thing we want to do is go to our event on possess to make sure that our controller also knows our location name. And over here we have our possessed pawn, so that's our card character. So we can use the interface over here to get our location name. So we're going to drag off the possessed pawn and do AI set location name. This will return the actual name, and we're going to promote this to a variable on our controller as well. So promote to variable, location name, that's fine. And then make sure we hook it back up so our blackboard and behavior tree are still working. Then we want to go to the part where we use our interface function. So for the change state event, because we added the inputs over here, so BPI AI change state, if we double click it, we can simply pass on the new inputs because they were already existing in our change state event. So we can simply pass them on like this. And now that we're here, we also want to make sure that inside of our actual AI change state event, we're going to add a check if we are alive or not. So we're not executing any logic behind this point if the pawn is actually dead. So let's grab a branch, plug it in, plug in the false pin over here, and then we're simply going to hook up our is pawn dead boolean. So we stop execution if we die. So with this part set up, we can actually start creating the functions that will alert AI near to us. So let's start creating that function. We're still inside of our AI controller, and we're going to add a new function and call this one alert nearby AI, for example. And we're going to give this a few inputs. The first of one is going to be the new state. So the state that we want to put the other AI in. That's going to be of the type our AI state enumeration. Then we need the location of ourselves. So that's my location. That's a vector. And we also need the search location. So we're going to add a second vector, and that's the search location. Then we want to determine the radius. So we're going to set the alert radius. And that's simply the radius within other AI is going to be standing if they need to be alerted. And then we need the spotted actor in here as well. So let's add a last variable, and that's the spotted actor. And that's an actor reference. So we have 5. That should be good to go. First of all, let's grab our alert radius, and we're going to multiply it with itself. So we're going to do a distance check, and for the distance check, we're going to use squared distances because that's cheaper to calculate. So we're going to convert this normal radius into a squared radius. So we're going to promote it to a local variable, and let's call this local alert radius squared. So we have that stored and ready to go. Then we want to double check our location name. So we're going to grab a branch. And we're going to check if our location name is not empty. So not equal to nothing, plug it in over here. If this is true, then we're going to get all actors of class with tag. So this one. And for the tag, we can actually use our location name. So this will make sure that we get all of the other AI with the same location tag. And for the class, we're going to select our GDR card. And if we don't have a location name, then we're simply going to alert all AI near us that are inside of the radius. So for this one, we want to get all actors of class. And we're not going to use the tag in this case. So we simply want to select the GDR card. We're going to promote this to a local variable. So that's local all AI. And make sure that we store it for both of them. And then we can grab a for each loop and loop through them. So grab for each loop, plug it in like this, and then plug in your local array. The first thing we want to do is make sure that this is not our own pawn, because that one is also included in this array. So we're going to grab a branch and simply compare the array element if it's not equal to our possessed pawn. So plug it in over here. That's our first condition. And if this is true, then we want to do our distance check. So we want to grab the actor location from the array element, drag off here, get actor location. And then from the actor location, we can drag off and do a distance check for the squared vector. So this one. And the second location is going to be my own location. So we can drag it off all the way to the input from the function, my location. Like so. And if this result is smaller than or equal to our search alert radius squared, so that's the local variable, then we're inside the radius and we want to be alerted. So we're going to grab a second branch, plug this in the true pin. This is our second condition. And if this is true, then we're going to call our change state event, but we need to get an AI controller for that. And this is the actual pawn. So we're going to drag off the actor over here and get an AI controller. And from the AI controller, we can call our BPI change state event. So the message event from the interface, we want to call this one, plug it in. And then we can grab these ones from the actual function. So the new state. the spotted actor and the search location, and we can simply pass them on like so. So this is pretty much the function that we need. Let's grab the completed pin and add a return node. So if we want to add something in here later, we don't accidentally continue working here, but we actually use the correct pin over here. Okay, so with this function in place, first of all, let's set things up if an AI finds a corpse, because that's where we ended off last video. So if an AI is going to find a corpse, we're going to make it alert other AI near us. So we're going to go to the event graph, and then if we go to our perception updated event, over here we have the little branch where we check if we have the tag for AI corpse, and if we do, currently we only print something. So from here we're going to continue. First of all, I'm going to grab the actor from the perception updated event. So that's the AI corpse that we found over here. And from this actor, I want to get a component by class. So the first one, component, not the components. And we want to get our stimuli component for the perception. And we're going to unregister it. So unregister from perception system. So this way, this corpse can only be found once, and it's not going to keep triggering new states if it's already been found. So we're going to disable the stimuli perception component, and then we're going to check our own current state. So we're going to grab our current state from the variables and switch on it, like so. And then if our state is idle or searching, then we want to call change state for ourselves. So if we're not doing anything and we're finding a corpse, then we're going to search the corpse location. But also if we are searching for a player and we find a corpse, then we're going to go to the location of the corpse, because we can't actually see the player if we are searching. We can only see the player if we are chasing. So for this one, we're going to call our AI change state event, so the normal one, because we're already on the controller. We don't need to call our message function. The new state is going to be searching in this case, and then we want to search to the stimuli location, so we can grab the search location and simply plug it into the stimuli struct over here, the stimulus location. We don't need a spotted actor if we are searching, so that's good to go. We want to do the same thing for the searching pin, plug that in over here. And now we want to alert AI nearby us. So we're going to grab our new function, drag it in over here, alert nearby AI. So we also want to make those AI searching, so we're going to change the state. And we want to plug in my location and the search location. So the search location is the stimuli location again. And we actually have our own location in this struct as well. So that's the receiver location. We can drag off here and plug that in my location, like so. And then we only need an alert radius. So I'm going to promote this to a variable so it's easier to manage. And that's simply our alert radius. Compile it, and then we can set a default. So for now, I'm going to set it to 1000 units, so we can pretty easily see inside of our testing level if it's working or not. So this should be pretty much it. Now we're gonna connect the chasing pin over here directly to the alert nearby AI as well. So this will make testing a little bit easier, but I'm gonna get back to this in a second because we don't actually want to do this. So at this point we should be able to perform a little test. So let's compile and save it. Then we might want to add a new AI in the level. So let's add a third one. I'm going to select the AI and the guard spot and simply duplicate it. And let's put it over here somewhere. And then we also want to set up the location names. So that's the new variable that we entered. And for now, I'm simply going to give all of them the same location name. So let's call this room 1. And do that for all 3 of the AIs. so they can alert each other if they want to. Save everything, and let's see how this goes. So I'm gonna hit play. There we go. So I'm gonna try and kill one of these guys. So remember, they will only alert nearby AI if they find a corpse, because that's the only place where we entered the new node. So this guy is chasing us right now. I'm gonna make sure I kill him outside of range of the other guys, so they cannot see the corpse currently. Then I'm gonna trigger this guy to start chasing me, and as soon as he finds the corpse, he should trigger that guy as well. Hopefully. So corpse found, and nothing actually happens, so that's cool. Perhaps the radius wasn't big enough, so let's increase the radius a little bit. Let's start by testing with a 2000 radius. Let's see, we have searching over here, so that should be good. Let's give it a second go. So where is my viewport at? Thank you. Okay, so again, I'm gonna try and kill this guy. There we go. So let's grab the other guy. And right now he found a corpse, and as soon as he did, he alerted the other guy as well. So that part is working as intended. So the radius was actually too small and he was outside of the radius. And now, for example, if I would grab this guy and give him a different location name. So I'm going to set him to room number 2 and the other guys are room number 1. So now he will not be alerted if the other guy finds a corpse. And by the way, I'm killing them by holding shift and then shooting at them. So I have a one-shot kill. If I would simply fire at them, he will go into combat and then all AIs will go into combat. So if I hold down the shift key, I'm doing multiple damage and that gives me a one-shot kill. So that's how I'm able to kill him without alerting the combat state. So there we go. Let's make this guy follow us. Let's kill him over here and alert the other guy. And now he should not alert his friend over here. So that's good to go as well. So that part is working, and now I want to refine this a little bit so it will also trigger other states with other AI. So not only if they find a corpse, but also if they start chasing and things like that. And for the combat state, I want to make sure that it's also using the radius and the location names and not simply alert all AI in the level. So back inside of our controller, so this is the part that we just set up and we can actually just remove this connection immediately. So this was mainly for testing this little part we just did to make sure that is working, but we're going to trigger this at another part in the graph. So let's remove this pin. Over here we only have the idle and the searching pin connected. Now we want to go to all of the AI change state events. And after all of those, we want to add the alert nearby AI node. So I'm going to copy this one and then right click, find references for this one. And let's go through all of them. So this is the actual event. Then over here we have the second one. So this is inside of the awareness loop. If we spot somebody close by, we immediately go into combat. So if we have other AI standing next to us, we also want to trigger combat for those AIs. So we can simply paste our new node over here, alert nearby AI, and hook it up. So in this case, we want to set the new state to combat, and then we do need the alert radius, so we can simply keep that plugged in. And we also need our own location, so we're going to grab our possessed pawn, and from that we're going to get the actor location and plug that one into my location, and then we should be good to go. So this is the first one. Let's move on to the second one, and that's actually also inside of the awareness loop function. And this one is when we actually spot an AI successfully and we start chasing him. So if our progress bar is filled up and we're going to start running after him. So again, we're going to paste our new node over here, alert nearby AI. This case, we want to set the new state to chasing, and then we need our own location again. So we're going to grab our possessed pawn and get the actor location, plug that into my location, and because we are chasing, we need a spotted actor and we don't need a search location, so we can grab the spotted actor and plug that into the for each loop, the array element. So that's the same actor that we are plugging into the AI change state spotted actor event. So this will make other AI start chasing them. I'm going to copy this again. And over here we have a bunch more of them. So that's the actual interface event. We don't need this one. And if we double click it again, then we have another one. Oh, this is inside of the perception updated. So this is for the gunfire. If we fired a weapon and we are actually really close to the player, we are immediately triggering combat. So over here, again, we're going to paste our new node. So plug it in and make sure that our new state is going to be combat. And for combat, we don't need a location or an actor, so that's good to go. If we go down a little bit, then we have the gunfire if we are seeing an actor or not. So over here, again, we're going to paste two of our new nodes and plug everything in. So we have the radius and our own location over here. And then we simply want to set the correct states. So for this one we are chasing, so we're going to set this one to chasing as well. And for chasing we need the actor, so we're going to grab the spotted actor and just follow the pin of the other node and plug it in over there. So that's the actor from the event. And if we are searching, then we need a search location, and we can grab that one from the stimuli struct over here, and that's our stimulus location. And for this one, we want to set the new state to searching. Okay, so that one should be good. So now we should have most of them, I think. Yeah, we already did that one, so that should be good. So in total, we should have 4 of these nodes added, and then the one we already had. So now the AIs should trigger each other, so we can do a quick test. For example, if we hit play, we still have the room names set up differently. So if this guy sees me, he will trigger the other guy as well, and that guy has a different room name, so that's why he is not triggered. So that seems to be working as well. To make this work a little bit better with the combat state as well, we're gonna set that up. So over here in our AI change state event, if we trigger combat, we actually go to our game mode component and then alert all of the AI in the level. So we're not going to do that anymore. I'm simply going to hold Control, drag off this pen and drop it in an empty location, and we're going to set our combat state simply for this AI. So combat state, the start combat state event. And if we do that, we are going to end up with a tiny little issue, because over here we also tell all of the players to remove the widgets from the progress bars. But currently we do not send all AI into combat, so we don't want to remove all of the widgets necessarily. So only for the AI that are in combat, we want to remove the widgets. So we want to tackle this a little bit differently, and we can actually do that pretty simple by changing some stuff inside of the controller over here. And what do we want to change? First of all, we want to go to our perception awareness loop over here. And so this is the awareness loop. First, we check if we perceive them successfully, if they are close. We're going to go to the second for each loop. And inside of the second for each loop, first of all, we do a switch on states. And in here, we also want to hook up the combat state. So if we are in combat, we're going to set the perceived time to -1. And that will actually remove the widget. So first of all, this will fire. It will set it to -1, and that will make the widget go. It will make the widget disappear on the actual player component, and then it's still inside of the arrays over here. So the second time this fires, this boolean will return false because it's already -1. Then we want to grab a switch on the state again, plug it into the false pin, and if we are in combat, we're going to drag it all the way down here to the remove index nodes. So this will make sure that the progress bar for all the AIs that are in combat will be deleted, and after that they will be removed from these arrays. And to make this work, we want to go all the way to the end of this function as well. So follow the completed pin from the reversed for each loop. And in here, if the state is combat, we actually disable the timer. So we don't want to do that because this will make sure that the arrays get cleared. And if the array is actually empty at the end, then the timer will stop because of this condition. But the array doesn't necessarily have to be cleared all the way. There might still be other AI that are not in combat that are perceiving us. So we want to make sure that this timer keeps running. So we're simply going to remove this condition and only plug in the perceived actors is empty array. And then the last thing we want to do is go to our start combat state event, because over here at the end we also disable the timer. And we don't want to do that manually because we have it set up that it's going to automatically delete if needed by the changes that we just made. So we're going to simply delete this part as well. Okay, so that should fix the progress bars. And now there's only one tiny thing we need to fix. Let me see. So let me grab a viewport quickly. So let's say I'm going to copy a few more of these guys over here and possibly over here. So, well, let me just show it to you. That's easier. So I'm going to play the game over here. So if this guy over here sees me, he's going to trigger the other AI and he's going to trigger the chasing state. But chasing will only work if the AI can actually see me. So if they are chasing and they cannot see me, they will call our getLastPerceivedLocation function, and that should return the location where they last perceived it. But we run into an issue because these guys behind the wall never perceived us at all, so they cannot find a last perceived location. So what happens is they will freeze in place. So over here, first they start chasing me, and then as you can see, they stop chasing because they don't have a last perceived location and they don't know what to do. So we want to go back inside of our AI controller. For the getLastPerceivedLocation function over here, we're going to make sure that this array is actually not empty. And if it is empty, then we're going to cheat a little bit, because then we're simply going to use the spotted actor location. So before the for each loop disconnected, we're going to add a branch, plug it in. The last sensed stimuli is not empty. That's going to be the condition. If it's true, then we can use the for each loop, and if it's false, we're going to grab a second return node, plug it into the false pin, and then simply get the actor location of the spotted actor and plug that one in. So this will make sure they start searching in the last spotted location of the actual guy that saw it, sort of. Okay, so save that as well. And now we should be good to go. So we actually have it set up that we can change the location names for the AI. So you can mess around with that as well and make sure that everything is working correctly. So this guy will not be alerted because he has a different room name or different location name. And the other stuff should work just like it did before. So let's make sure they actually start searching if they cannot see me. So that part is working as well. And now they all going to look around a little bit, and if they can't find me at all, they will return to their original location. So that's good to go as well. And now we can take him out, for example. And they will start searching the corpse because they couldn't see where I was shooting from, or they couldn't see me. Okay, so we refined the behavior a little bit, and we made sure that it's actually workable inside of a level with multiple rooms or multiple floors, and you don't alert all of the AI at once. So I think we're getting close to actually start setting up the combat. So we probably start doing that in the next episode, but we'll have to see. This is all I got for you guys today. Hope you enjoyed the video. If you did, please consider leaving a like. I'll be back soon for more. Later, guys and girls. Bye bye.